Assalamu alaikum wa rahmatullahi wa barakatuhu. Dear students, welcome back. So now the first chapter of U3 is over. Now it's the time for the next one, and that is our chapter 12, Light, and it's on page 145. So here it is. The world is largely known through the senses. As we know that we know the world around us by our senses, like by seeing something, by hearing something, by just feeling something, by smelling, right? So it's our senses that make us know about the world around us, right? The sense of sight is one of the most important senses. Now the sense of sight, that is we see with our eyes, right? So the sight is possible only because of our eyes, so it is one of the most important sense. Though through it we see mountains, rivers, trees, plants, chairs, people, and so many other things around us. So with the help of our eyes, with the help of this sense of sight, we are able to see the things around us, like the mountains, the rivers, the trees, the plants, everything. Okay. We also see clouds, rainbows, and birds flying in the sky. That's true. At night we see the moons and the stars. That is also possible only because of the sense of sight. So we are also able to see the words and the sentences that are printed on the paper, like just like now. I'm able to see these words with the help of my sense of sight. How is seeing made possible? How it's right, it's true that we see, but how is that a phenomena? How are we seeing the things, right? What makes things visible to us? So have you ever thought how we see the various objects? How do we see them, right? What is the phenomena? How are those things made visible for us? You may say that eyes see the objects. Yeah, we know that we normally in the layman we say that our eyes, they are seeing the objects. But if that was the case, that only eyes are responsible for seeing something, so do we see in the dark? No. Why? Why eyes are also there, na? It means that eyes alone cannot see an object, right? So it's clear that it's not the eyes only that are responsible for seeing any object, but it is only when light from an object enters our eyes. Okay, see, this is an object. When the light from this object is entering our eyes, then only we can see it. In the dark, the light is not present there. Okay, that's why the object is not visible to me. The light may have been emitted by the object or may have been reflected. Now I am seeing that, see, light is incident on this, that is falling on this paper, right? So the case may be that the light is reflected back or that is emitted by the object, right? But that when that light either emitted or reflected, that just enters my eyes, I am able to see that particular object. You know that a polished or a shiny surface can act as a mirror. We know that. Okay, a mirror changes the direction of the light. Okay, when the light is falling on a mirror, the mirror just changes its direction. Can you tell in which direction the light falls? No, let's find out with the help of these laws. These are the laws of reflection. The activity first, that is 12.1, is like fix a white sheet on a paper on a drawing board. I'm fixing it up. Take a comb, this is the comb, and close all openings. I'm just closing all the openings except one in the middle. Okay, so you can use a strip of black paper for this purpose also. Okay, now hold the comb particular. See, it is in the paper is like this, so I'm holding the mirror like this in the perpendicular direction, the 90-degree angle direction. Okay, throw light from a torch through the opening of the comb. Now through the opening of the comb, see, this is the opening of the comb. What I am doing, I am throwing a light with the help of a torch. Rest all is blocked. Okay, with slight adjustment of the torch in the comb, I am seeing that a light is incidenting on it, right? See, this is a ray of light that is on the paper. Keep the comb and the torch steady. Place a strip of a plain mirror in the path. Now what I am doing, I am just placing a mirror here. Okay, in the path of it I am placing a mirror. So what I am observing, see, after striking the mirror, the light from this comb is passing and it's striking the object. The ray of light is reflected in another direction. See, the light was incident like this, but now it's being reflected in this direction, right? it was the incident light which was passing through the comb and falling on that mirror. Now mirror has a capability to just reflect it, to just either emit or reflect it in different directions. So it is being reflected in this direction. So what do we see? We see that it is reflecting it, right? So this light, this ray that was falling on it, it was incident light. So what is the incident light? The light ray which strikes any surface, that is the incident ray. Now this ray that comes back from the surface of a reflection, whether it's being transmitted or being this emitted or being reflected or refracted, that is the reflected ray. Fine. This is the incident ray and this is the reflected ray. Incident ray is that ray that is falling or striking on any surface, and the reflected ray is that ray that comes back from the surface after reflection. See, we say that a ray of light, but a light doesn't have a ray. It is made composed of many different rays, right? But for the simplicity, we are using the term a ray of light. But light cannot have a single ray. It is composed of different rays. Now it's being said that we have to just take out these things, and what I have to do, remove these mirrors and this, draw the lines. I have to draw these lines first, right? This line and this line and this, just like this. I have to just mark the points like this. This was my mirror, this was an incident ray, and this was a reflected ray. Okay, so there is one more thing. Now draw a line making an angle 90 degree to the line representing the mirror at the point where the incident ray strikes the mirror. This line is a normal ray. Normal means basically the perpendicular. See, here I am drawing a perpendicular, but it's being said that where there was a mirror, just draw a normal. Normal means draw a 90 degree line here. So it is a 90 degree line. This is known as the normal, that is 90 degree line. The angle between the normal, this normal, and the incident ray is known as the angle of incidence. See, let me show you here. So it was my mirror, right? This was the incident ray and this was a reflected ray. True. So it's being said that we have to draw a normal line. That means a line perpendicular to this line, to this mirror. So this is the normal perpendicular and 90 degree line, simply 90 degree line. So the angle that is made between this normal and incident, that is known as the angle of incidence, and the angle that is made between the normal and this reflected ray, that is known as the angle of reflection. Fine, this is the incident ray and this is the reflected ray. Now, do you see any relation between the angle of incidence and the angle of reflection? Are they approximately equal? So when we'll just see this experiment and carefully we will observe that the angle of incidence is always equal to the angle of reflection, and this is a law of reflection. So what is our law of reflection? It is that the angle of incidence is equal to angle of reflection. Okay, this angle is equal to this angle. That's all for today.